All right, so welcome everybody back to Ecolunch. So as a reminder, these are our casual lunchtime presentations where we're trying to kind of foster a culture of learning, sharing science, and collaboration. Anybody can present at these, so please reach out to me. I am trying to do this kind of theme thing just to kind of make it more fun and help us wrap our minds around the science that we're doing in a different way, but we can always shake that up depending on who wants to present when. And this is our first of 3 shorelines and marshes series. And today's topic, we'll be learning about marsh science, as you probably guessed, given the warm-up question and the send-aheads, aka Marsh Madness. And we'll be hearing from Megan and Julian today. Next up, we're going to have Jamie Miller talking about beach science, and following that, we'll move inland to agricultural wetlands and birds with the Nature Conservancy's Rod Kelsey, and Catherine Hickey's going to co-host that one with me. I'm super excited for the next theme as well, which is partnering with Indigenous people and local tribes in conservation. So we'll be hearing from some of our staff who have begun to do that. So stay tuned for more on that. As a reminder, I do add links to the recordings on the Comms Hub, which you can find at pointblue.org/commshub, and there's an Ecolunch tab. So that's your little intro to Ecolunches, and let me get on to our intros of our speakers now. So we'll be hearing from Julian Wood first. He is our San Francisco Bay program leader. And in that position, he works to promote conservation actions that address climate change and land use change in ways that benefit human and wetland bird communities throughout the Bay Area. His passion for nature began at a young age in the weedy edges of lakes and rivers in Michigan, and evolved into an interest in birds after an influential ornithology course at Earlham College in Richmond, Indiana. So since then, he's attempted to develop a deeper understanding of birds, their environment, and how interactions with them can be positive. His work at Point Blue, which began as an internship at the Palomar Field Station in 1996, has taken him from Montana to Mexico, studying bird ecology and grassland, riparian, and wetland habitats. And he splits his time between the East Bay and our Petaluma headquarters sometimes. And after Julian, we're going to hear from Megan Elrod. And Megan is our San Francisco Bay biologist, maybe librarian. I'm not sure what state that is in these days, and also Antarctica biologist. So as a biologist in the SF Bay, Megan spends most of her time out in the tidal marshes, monitoring bird response to restoration in the estuary and keeping tabs on the federally endangered California Ridgeways rail, formerly the Clapper rail. And yes, that's Ridgeway spelled without an E. Tricky one to say and spell. Megan grew up in Louisville, Kentucky, and received her undergraduate degree in biology from Milligan College in East Tennessee. She also began working as an intern at Point Blue's Palomar Field Station, and that's where she solidified her desire to work in the field of avian ecology. Field work has also taken Megan to lots of awesome places, from ground nesting Philoscopus warblers in Siberia to cooperative breeding purple-crowned fairy wrens in Western Australia, and the not-so-monogamous rusty blackbirds in Alaska. I think you guys need to ask her more about that later. Most recently, she has expanded her avian studies to include seabirds, specifically penguins, with our Antarctica team. And that's not super recent. I think I need to update your bio on our website, Megan. She's been doing Antarctica work for quite a few years now. So if she's not driving a boat down the slough or getting stuck in the mud in a marsh somewhere in the SF Bay, she might be at her home in Bolinas, still out birding, or maybe shredding some brown pow somewhere on her mountain bike. I learned that term from Megan. So thank you so much for sharing your work today, Julian and Megan. And as always, please write down your questions as we go along. We will have 2 presenters today again, so make sure you're jotting them down. We'll do Q&A after they both co-present. And with that, I'm going to pass the mic to Julian.
Awesome. Thanks, Lishka. That was great introduction. Very, very thorough. And thank you for hosting these. And I've managed to attend each one so far, and they're great. So I really appreciate it. Appreciate the invite. So yeah, Marsh Madness. You can probably guess who came up with this title, the one from Tennessee, sorry, Kentucky, who's into basketball. So hopefully you get that pun. This is really going to be kind of an overview of the San Francisco Bay program. So we won't dive too deep into any one particular thing that we're doing, but yeah, give you kind of an overview. But yeah, first, Marsh Madness. So give you a chance to like read this. Is pretty funny. When I saw this, I instantly thought about our Marsh system. So as I'm going through the presentation, you have to think about some of the species and which ones you want to put your money down on. Okay, so a quick outline, talk a little bit about the program background, and then I'm going to move into how we're working with straw on their transition zone restoration, and talk a little bit about Ridgway's rail conservation, so that's a big part of what we do, and also our San Francisco Bay Keystone data set, and then kind of wrap it up with what's next, what we're going to be up to. Oh, and before I get too far, just want to give a big shout out to obviously Megan, who did the bulk of the work putting these slides together, and also to Nadav Noor, who I see in my little window there, who has done a lot of the analysis along with Leo Salas for a lot of this work. So yeah, big thanks to them. They're the sort of the analytical powerhouse behind a lot of these results. And also shout out to Hillary Allen, who's helped out a lot with our field work, and she'll feature prominently in the What's Next. Okay, so the San Francisco Bay program. There's our mission up there, not too dissimilar from our org mission, and we achieve that by monitoring and doing research to better understand threats and develop solutions and strong partnerships that improve restoration and management in the Bay. So moving on, San Francisco Bay program. So we have a 20-year, pretty unique data set. We're out there monitoring some birds that no one else in this region is really looking at. So we're kind of the only ones keeping tabs on a lot of these populations that I'm gonna cover as we go along. And yeah, so this program was started actually by Tom Gardali in '96, who's actually no longer with Point Blue. But in those early days, we really wanted to know what was the status of these marsh birds. No one really knew exactly what their populations were doing, whether they were going up or down or how big they were. And some of that early work led to some of the species describing their status as listed species. And so many of them are bird species of special concern as part of that work. And also kind of more recently, we've invested a lot in forming really strong partnerships with state, federal, regional agencies, other entities, academia, other NGOs, and really helping them with their projects, their on-the-ground restoration and planning projects, and also policy. So here's one testimonial from the South Bay Salt Ponds project, which is the largest wetland restoration project on the West Coast that we have been pretty heavily involved with from the beginning. And also wanted to point out some folks who've been involved in the San Francisco Bay program. You might see some familiar faces. Type them in the chat if you know who these folks are. Extra credit if you can get them all. Okay, little pause there while you're while you're busy typing away and scratching. Oh, I think I know that guy. I've seen him before. I want to back up a little bit and sort of tell you why this program is even important, why tidal marsh. For those of you that gave tidal marsh a 1 in the in Lishka's questionnaire, this is for you. No, I'm kidding. But we've lost over 80% of this habitat, which isn't very large and extensive to begin with, because it really only occurs in sort of sheltered waters, shallow sheltered waters that are tidal. So already it's pretty limited. We're lucky in San Francisco Bay that we have a lot of those areas. But still, in the whole scheme of things, this is a pretty rare habitat globally, and obviously at risk with from sea level rise, which I'll get into in a bit. But so that map on the left shows what the original sort of pre-settlement tidal marsh extent looked like. All that green was tidal marsh, and on the right is kind of what it looks like today. And it's actually hard to see the green on that right-hand map. There's just not much remaining. And a lot of that yellow it's still wetlands, but it's diked off, so it's no longer tidal. All the gray has been either urbanized or filled for agriculture and other purposes. So huge losses there. And then also, like, what remains is pretty fragmented and impacted by mainly by urbanization in a lot of places, but all those other uses. So this is the Bay Bridge toll approach to the Bay Bridge toll. And there's a big sewage plant there, and you can see on the right hand, like, the marsh is kind of just hanging in there, squeezed on the edge. So that's a lot of what these animals are left with. So luckily, here in the Bay Area, there is a lot of interest in water quality and preserving habitat for species. So there's been a lot of restoration, and tidal marshes, or this area does respond quite well to restoration. So the marshes do come back. So when these, I didn't really get into it, how marshes are lost exactly, but effectively, if you put a dike around a marsh and you pump the water out, you lose the marsh. And to get that back, sometimes it's as simple as punching a hole in that levee and then letting the tides flow back in and letting that marsh build up again and slowly vegetate, which is what those two photos that are only a year apart look like. So sometimes these marshes can come back very quickly. And so, yeah, like I said, in the Bay, we're pretty lucky that there's been so much investment. Over 300,000 acres have been restored since '99, largely from that breaching of those levees. And there's billions more invested, and a lot of that is coming through the Measure AA, which is that parcel tax that we voted for way back when. So now what that looks like is this slide on the right now, or the map on the right. You can see all these, the light green is the existing tidal marsh, and the darker green are all restored tidal marshes. So, and then the darkest green there are planned restoration. So you can see it's actually starting to approach that, that original outline, which is super exciting. We're not going to get all of those marshes back, but it's pretty amazing what we've accomplished so far. Now to bring it down again, sea level rise is a huge issue for tidal marsh, as you probably guessed. It's marshes sit right at that mean high water mark. So any changes in sea level radically affect the tidal marsh habitat, and they can be easily drowned if there's not enough sediment coming in to help the marshes build up that elevation and keep pace with sea level rise. Kind of breeze through that. So, but this is what it looks like. So this is during a king tide, when you've got the the sun and the moon line up, and you have these really high tides that happen a few times a year. But the marsh habitat, which is normally covered in vegetation, is completely inundated. And so at this site, Baumeister Marsh in East Palo Alto, so there's rails in there, there's song sparrows, there are salt marsh harvest mice, an endangered species that exist only in tidal marshes. You know, where do they go? They're left to kind of hang on to these tiny little patches of veg that stick up, and they're very vulnerable to predators and to just the water itself, to exposure, since a lot of these highest tides co-occur with storms that make the waters rise even higher. So clearly, that vegetation that is remaining is really important for these animals to survive these sort of events. And so sometimes you can get that within the marsh, like in the photo, you sort of saw some veg sticking up. But in a lot of cases, that habitat is really on the edge of the marsh, where the land kind of meets the marsh. And kind of circled here, that is what is called the transition zone, where you have the marshes transitioning into the uplands. And often that area on the edge of the marsh is the only place where animals can find refuge during these high water events. So that brings me to the straw restoration, the straw program. I'm sure you all know what that stands for by now. Students and Teachers Restoring a Watershed. And they have been doing a lot of work restoring this transition zone in the North Bay. A lot of times these transition zones are just, you know, weedy, grassy. There's not a lot of vegetation structure, not a lot of places for birds and other animals to hide. And so by planting it with native shrubs and other plants, it provides that cover that birds need. Real quick story. So when we first started working with straw, and they were asking me, oh, well, you know, we're doing all this work to restore the transition zone for these birds. And, you know, our funders want to know, like, how is it impacting these birds? Are they, you know, is a healthy transition zone really related to a healthy marsh bird population? And I thought about that. Yeah, I'll look. I'll get back to you. I looked. There was really no information about how a ridgeways rail, for example, might benefit from a healthy transition zone. Just it wasn't out there, so I had to go back and say, I don't know. There isn't really anything. Just say it's good. Everyone will believe you. So that got me thinking, we really should look at this. We have the data, and we should really figure this out and be able to say, not only is it helpful, but how can we make that habitat even better, even more beneficial for rails? So that's kind of what we set out to do with our what we call the T-Birds project, looking at transition zone health and related to birds. So these are some of our sites that we worked on. Looks like I lost the labels on there. But anyway, that top right is out at Sonoma Baylands, and top left is the Schollenberger right out front of the office. And those bottom ones showing some natural transition zones and some flooding. Oh, there are the labels. They popped in. Good job. So what we looked at was the vegetation characteristics in the transition zone and how those related to bird densities and bird health, I should say, in the marsh. And we found a significant relationship with song sparrows related to dense vegetation in the transition zone. Now, normally this wouldn't be like groundbreaking result because, yeah, birds like dense vegetation. We found that again and again. But this is a little different because we're looking at the characteristics of the populations in the marsh and looking at the veg in a totally separate place, like all the way in the edge of the marsh. So well outside of their territories. And we still found a relationship, which is pretty cool. So to us, that said, yeah, these birds actually need that habitat that's way over there on the edge of the marsh in order to survive. And so we have quite a few graphs, different species and different habitat characteristics that I'm not going to get into. We won't have time. But, well, real quick, we'll show you the ridgeways rail. So a similar looking, this one is looking at veg height. So the taller the vegetation in the transition zone, the more positive are the trends of ridgeways rails in the adjacent marsh. So here I'll take a little pause. I've introduced the ridgeways rail. This is an endangered species that is really driving the restoration in the bay. They were listed in 1970, and their populations are extremely small and very susceptible to extinction. So that's why they're listed. And Megan will take over and talk a little bit about the Ridgeways Rail and what we're doing currently for promoting their conservation. So we've got a question while we transition. The Ridgeways Rail, bit of a tongue twister. Used to be called the Clapper Rail, which is a little bit better. That's kind of what they sound like. But there's got to be better names, right? So put it in the chat. Can you think of a better, what would you call the Ridgeways Rail? Take that in the chat.
I think we have successfully switched over. You probably can't tell because I'm showing the same slide.
Seamless.
You can hear me all right though.
Yeah, we'll collect your answers at the end. So
Okay.
yeah, take it away. Marsh.
Yes, so thanks, Julian. He started talking about the Ridgeways Rail. Another sort of sad name for them is their Latin name. They are doubly obsolete. They are driving a lot of this restoration that Julian was talking about because they are federally and state listed. And so one way that we can drive restoration and set metrics for this is through recovery plans. And we have one for the tidal marsh in San Francisco Bay. And by we, I mean, it's us working together with lots and lots of partners with a goal to have a abundant and resilient native tidal marsh. And we need a lot of monitoring to understand the changes that are happening and if we are successful in our restoration efforts. It also gives very specific population numbers for the Ridgeways Rail. And so we are trying to get to 5,492 individual birds to delist them. That also translates to some growth metrics. So some looking at trends and different rates in different parts of the bay. And so we have different efforts and metrics. Like I was saying, there's, we need a population estimate to understand what we're doing and how we're reaching that goal. And so we did that in 2012 and we are currently doing that. And I'll go into that a little bit more. But also we're trying to encourage this process to lean more on trends to understand the population. We can do that with a little bit more confidence to say what's happening. So to get at this, we've had a different our previous population estimate in 2012. We had a lot of challenges. There's all these partners in the bay, and they're all collecting data on Ridgeways rails with different protocols. And even within our main protocol, the type A, everybody was collecting that a little bit differently. Just minor differences, making it difficult for us to put it all together and understand what was going on. There's also a lot of different versions of Excel, just piling on the headache. So we finally reached, in 2017, we reached an agreement on a protocol and we call it the North American Protocol for San Francisco Bay. And it is a 10-minute point count, and we broadcast for Black Rail and Ridgeways Rail, and broadcasting is doing playback of their calls to make them respond, because otherwise they're extremely secretive marsh birds, the other name you hear for them. And so we're trying to hear them, and we definitely hear them more often than we see them. And then we go out into the same place 3 times per season, which is January to March. And then the map shows places that we're monitoring in San Francisco Bay, and that is us and our partners. And this is everybody who's working together, putting their data in the AKN, which is awesome. I get, it was a lot of work, a lot of thanks to Doug and Martine making it happen. It's a crazy data set. You can ask them about it. So we got our data in the AKN, super exciting. For our population estimate that we're looking at now, we're doing 2019 to 2021 survey data. And this is kind of breakdown of the area and sites that are broken down by the different, by various people that surveyed them. We put this data through a whole lot of filters, and we got down to our data set that we can analyze. And we overcame all these like issues with the protocol, but we still have a lot of problems because Ridgeways rails are hard to count. And so this is like a few slides of laundry list of challenges with this data. We love the rail, and we persevered through understanding all of this. Like I said, they're hard to see, so we have to come up with a way to count them and estimate either if they're really not there or we just didn't hear them, how many rails we're missing. So probability of detection plays a super important role in this work, and we ended up using some information from a radio tracking study that USGS did, as well as our pilot protocol study, which we completed back when we were going from all those different survey protocols to one protocol to rule them all back in 2014. We got a solid probability of detection. And not only do we have changes and issues with detectability, we also have changes on the landscape. Since 2012, we've had changes in elevation and salinity. We have odd distribution of sampling stations. We also have trouble consistently counting the same number of birds. This graph shows our 3 visits, count 1, 2, and 3, to a given survey station, and that our counts can go from 21 to 4 to 18, or more extreme, 15 to 0 to 0. How many birds are actually there? We also missed out in 2020 with round 3 at a lot of sites because of COVID. So thanks to Leo and Nadav. You can ask them all the very complicated modeling questions. We came up with a slightly different approach to estimating the population size this time around. It's pretty cool. I like it. It makes sense. We're using a lot of information about the landscape to better understand, to better model where the birds are versus just relying too much on our point estimates when we're standing there at one place counting birds. We're only using detections up to 200 meters around a survey station. So there's a lot of marsh out there beyond what we're counting. We also were able to use those 3 years combined, which is nice. We were getting similar abundance in all 3 years. We did this in 2012 as well, kind of looking at some landscape features that are important to the Ridgeways Rail. We got like slightly different responses this time. I think is interesting. It's kind of something we can explore more in the future. They still really like a higher salinity, but that curve sort of shifted this time around. So in 2012, it was like all the way at 25. That's in PSUs. And now it's down at whatever that is, like 18. So we might investigate like drought or other changes on the landscape that may have made that shift. And so we took all of those covariates on the landscape and we took all our survey data and we took our elevation modeling that Sam has worked a whole lot on with sea level rise modeling and what kind of same models went into our CoStar future. And we came up with rails predicted on the landscape and so darker colors are higher density areas. This is showing the North Bay, and you can orient with knowing where our office is. And so we're kind of interested future explorations of what's happening with restored areas versus older marshes. The rails like some of the restored marshes up in the North Bay. And we have a number hot off the press. You're seeing it here almost first. It's draft. Should have put a big sticker over it. Draft, watermarked. Yeah, so we broke those numbers down by bay with that landscape density raster. Okay, that's a lot about rails. But sometimes, as I was alluding to with the restorations, sometimes the rails aren't there. For example, Pond 2A, Napa Sonoma Marshes, Lishka, it is the marsh that is your background. That's Pond 2A. It was restored in 1995. And so like Julian was talking about earlier, the processes of marsh accreting after a restoration, the vegetation comes back, but depending on salinity and the location in the bay and other landscape factors, we might not have Ridgeways rails, but if they're the only ones driving restoration and funding, might give up on Pond 2A because there's no Ridgeways rail out there. Why is that important? We care about other species here at Point Blue. For example, the common yellowthroat loves Pond 2A. So this is looking at as the marsh restores and gets vegetated, common yellowthroats went nuts. And black rails also responded well out at Pond 2A. They occur in lower densities, so we just have fewer of them. So this is a fun sort of visualization, I think, of why we study all of our different species to look at the health of the marsh. We have our Ridgeways rail. We want to understand how marshes are doing. We could just take the temperature of just the Ridgeways rail. But what about the song sparrow and the yellowthroat or the black rail or the marsh wren? We only protect the Ridgeways rail gonna leave everyone else out in the rain. But we want to study all the species, and they have different habitat requirements, and we can protect and grow all these species as we restore marshes. And together, they are the best indicator for a healthy tidal marsh. And some of our other findings with kind of this crosswalk between species, this is also from the same, the straw study with looking at transition zones, and Annie Schmidt got to help out with this work. We try to like bring in a lot of people to work on our projects. I don't know if you notice throwing out all of these names. If you have interest in the tidal marsh, let us know. You can work on our vast data set, or get money, both available. We have song sparrows and ridgeways rails with correlating trends, just super cool. And so we can have both ridgeways rails and song sparrows in the marsh. And so we had all this data, we had, you know, established this work, and but our effort has fluctuated over the years with being able to survey, and it's all been driven by funding. And so we came up, we sort of planned or pitched the Tidal Marsh San Francisco Bay program as a keystone data set to keep it funded and to be able to focus on the science and not just work wherever we were able to get money. And so with some of that work and with the Keystone designation, we got Nathan Elliott to work on some super fun summary code that looks at our long-term data. And so this is some of the like output on this of our study species. And this is a few sites in the North Bay all together of both restoration and unrestored historical marshes. And this is some in the South Bay. And so we're using all this data to support decisions, both internally. It works, the Keystone data works to support our initiatives. And so like Julian said, historically, we had this go into things like the Baylands, and then we had it go into future marshes, and most recently, SFEI's and the estuary blueprint. And Julian's taking back over for a quick what's next.
Well, what's next in a time check?
10 minutes.
10 minutes. Oh, geez.
Go quick.
And what's next? Well, we're starting up a project in the Delta, working with Christy Dybala, and kind of a phase 2 of the Delta Multiple Benefits Project, which had left out a lot of the tidal marshes in the Delta, which are even more scarce in the Delta than they are in the Bay. So we're looking for specifically some of those listed species that are hard to detect on our point counts, and we're going to use the ARUs for that, the automated recording units. So that photo down in the bottom right. Most of these sites are like boat access. It's the only way to get out there. So it's intensive to get out there. So we thought putting these units out there will help us sort of maximize our ability to detect things like least bitterns and black rails that are really few and far between out there. But we need to know where they are and what their habitat associations are to help build that model to study where restoration should be prioritized in the Delta to maximize the benefit to these birds. Another thing that that I've been doing, but we want to do more of, expand, is looking at, I'll call it innovative marsh enhancements for sea level rise. And that is a technique that where sediment is placed on top of the marsh to sort of build up the marsh elevation into a little mound. And that mound is vegetated with marsh vegetation. And that provides the refuge for animals to go to when the rest of the marsh is flooded. Which in theory, that sounds great. But in practice, we don't actually know how well it works. Who's using those mounds? Are predators also using those mounds? So we set up some trail cameras as a test. I was super excited to actually like get some good photos, get this great blue heron cruising over, and then got super lucky. And down there in the lower left is a ridgeways rail. And you can see like the water level. So that mound is already probably a half meter or so above the surface. So we're talking deep water here. So yeah, so we got the ridgeways rail. So I was like, oh yeah, we got the rail. You know, the mounds work, they're great. And then like the next photo is this one. And if you squint, if you look on the left, on the very left side of the, maybe mouse over it, you can see a harrier's tail sticking out through the veg there. So predators are also using the mounds. So we want to kind of better understand like what's happening there, what the dynamics are, and ultimately ask, one, are the mounds helping or hurting? And two, if they are helping, how can we improve and make them more even better? Different vegetation we planted on them, different configurations, lots of small mounds versus a few larger ones. These are the types of questions that managers want to know and turn to us to help address. So that's a bit what we're doing in the future. Hillary's going to be helping with that, both the ARUs and also the camera work. So yeah, I think we'll end there. And so yeah, who won? How did your bracket do? Who were you rooting for? Which species? We want to know. Type it in the chat.
Type it in the chat and type in how much you love marshes now, scale of 1 to 5. Thank you guys. We have 7 minutes left for questions. So please use the hand raise function in the reaction section, or type your question into the chat. I'll be scanning the chat. I think Grant had a question. What was that, ridgeway rail swimming?
Yeah, it was definitely the water rose up to the bottom of the camera, which was about this high off the ground. So yeah, it was in, I would probably guess like 15 centimeters of water. Yeah.
Nice. And we've got a question from Annie. Go ahead and unmute yourself there.
Sorry if you said this already, but I didn't catch, what is it about salinity that's important to the rails?
Yeah, that's a good question. I'm not sure if we know the exact mechanism. It's probably related to their diet, to what they like. The invertebrate, like whatever invertebrate species, they do love crabs. It's one of their main prey items. It may also be related to the fact that the South Bay tends to have higher density rail populations and is also higher salinity. So, you know, it could be that salinity is the covariate that's best capturing that variability. In other words, it's unlikely to be the actual salinity itself that is driving that, but
Right.
happening through other variables.
Cool. Thanks.
And
Can
that's
I just add?
one of the main
Sorry.
reasons why like we don't see them in Sassoon or in
No.
the more fresh brackish places in the estuary. Yeah, no.
Sorry, I was just going to make what you just said at the end of that sentence, which is to say they're not in brackish at all. So unlike black rails, which you mentioned, which are kind of more broadly distributed. So yeah, just this San Francisco Bay. Yeah, I'm glad you mentioned about the San Francisco yellowthroat. That I want everybody to know about that.
Awesome. All right. Any other questions? Use your hand raise function or the chat. And while we're waiting for more questions to come in, what does a rail nest look like? Do we know?
Yeah, it's like a kind of a platform of woven reeds and marsh grasses that sits just a little bit above the marsh surface, and often has either a woven roof of grasses over it, covering it from above, or it's underneath kind of what we call rack, dead vegetation that forms mats that are kind of perched on top of the vegetation, and they'll put their nest underneath. And in some cases, those platforms are loosely kind of held onto the more vertical pieces of vegetation, and they can actually float a little bit up and down with the tides.
Wow.
So they can survive some level of inundation, the eggs, but like chicks are going to be much more vulnerable to inundation.
I put a picture up it's on the right there.
Yeah, they can be pretty hard to find. I've only seen like 2 or 3 in my whole career trumping out there.
Yeah, that's.
I mean, I'm not like specifically looking for them because it's sort of impactful.
Yeah, it's hard enough to find the actual birds themselves, right? So
Yeah.
then finding their nests.
Mm-hmm.
Yeah. Their revised name has to have something about being sneaky or secretive in it. I haven't thought of the right one. Okay, any other questions about the science or anything else you saw in the presentation?
Couple in the chat. Oh yeah, well, we already answered that. Was the rail swimming? Yeah. Sorry. They do swim. We sometimes see them swimming across channels. It's kind of humorous when they try to do that, but they can. There you go.
Oh yeah, and from Meredith, any recommendations on where to see ridgeways, rails, and other cool marsh birds in the bay?
Yeah, I can speak for the East Bay. And well, one of the best places used to be the MLK shoreline, specifically Arrowhead Marsh in San Leandro. Yeah. Has fewer rails now, though, interestingly. It's still a good spot to see them. Another good spot is Galenas Creek area, specifically, help me out, Megan. What's that site? Yeah, I guess just out past the sewage ponds where the tidal marshes are.
Yeah.
You can see the channels there.
Yep.
Sorry, is that McInnes or not?
Yeah.
Yes.
Okay.
And then taking the path around north towards Hamilton Restoration. That's a good, nice walk.
Yeah. Yeah, I was gonna say it's a good walk, a good hike.
Bay Trail, you can walk and see Older Marsh and the restored Hamilton Baylands.
But they are often more heard than seen, and their peak calling is right around sunrise and right around sunset. So if you find yourself in a tidal marsh around those times, you can listen for like off in the distance, and that's their call. And they tend to all go off at once too. So one goes off and it triggers everyone in that same marsh, which is super fun for data collection.
And what times of year do you ask people to come out with you on boats?
Mid-January through March.
All right.
That's the survey season when they're most vocal, sort of setting up territories and getting ready to breed.
Sweet. Okay, 1 minute left. Any last questions from anybody here? Last questions. All right. Awesome. Well, thank you both so much for this presentation. Very informative and nice to bring light to this underappreciated habitat through history and this very secretive hidden bird. So thanks for doing your awesome work to bring light to these important species and share it with us. Thanks everybody for joining, and we will see you next week, I think. Yeah. With Jamie Miller on beach science. So yep, enjoy the rest of your day, everybody.
Thanks,
Bye.
everyone.
Bye. Thanks for joining.
Bye.